This video is on introduction to survival analysis. Survival analysis is a type of modeling technique which is used to model time to an event. The example of time to an event is time to death after heart attack, time to loan payment, time to get a job after graduation. We often need to model for the time to happening of an event. For such a model, to build such a model, we use survival analysis. Question arises, why can't we use the linear regression? What is wrong with the linear regression models that we cannot model for time to event? To model for time to an event, we cannot use linear regression for three main reasons. First, the distributed outcome, time to an event, is usually not normally distributed. The second thing is censoring. Censoring is nothing but a partial information. In time to event data, sometimes some of the observations are not fully observed, in the sense that sometimes we do not have full information about a particular outcome. We cannot take such an observation in linear regression analysis. We can take it in survival models. That's a special feature of survival models. And then the last thing is that we may not have the dependent independent variable relationship all the time. Sometime we only be having the time to an event, or what point of time an event happened. We don't have any independent or explanatory variables associated with the time to an event. If we do not have an independent set of variables or explanatory variables, we cannot use linear regression. But if you only have time to an event, only we have the duration. That is all we have. Whether it's heart attack, whether it's loan payment, or whether it's getting a job, we all know that okay, this is my beginning period, and at this point in time the event happened. That is all we have. We can model. So we can model for the time to event using survival model in such a scenario, even without having explanatory variable. We cannot, of course, do that using linear regression. So that's the basic difference, or the main difference between the survival analysis and the regression based models. There are a few requirements. First thing is there should be clear definition of an event. What an event? What is death? What is default? What is getting a job? There should be clear cut definition of that. Should not be any confusion at all. Then time scale. Are we measuring in terms of the month or year or days? So that is very important. That should be clearly defined. Again, origin of the event, like when it starts. Okay, for example, if you want to we want to monitor like when a particular customer is going to default in the payment. Well, the observation will start from the day the customer takes loan from us. From that day onwards, we will be observing the customer. So the origin of the event should be clearly defined. Time to event. Time to event is considered to be a random variable which can take any value from 0 to plus infinity. It can take any value between that. And we are interested to know what is the time to variable. How do we know actually for a particular event? For that, we need a population data to do the modeling exercise. Some peculiarity with the survival analysis. the individuals in our population do not enter the study at the same time. Well, they can enter the study at different point in time, still we can use them all in the model. That's a very uh, special feature of survival analysis, which is of course not there in other kind of models. When the study ends, some individuals still haven't had the event yet. For example, if you are doing a study on a patient who is undergone a heart surgery, is when is that person dying after he has undergone the heart surgery, and your time window for which you are doing the study, say for example, assume that the time window that you have taken for study is 5 years. Okay. If an individual is not dying in that 5 year, well, that can be considered as a censored event, because after that 5 year, fifth year, we don't know what is going to happen with that individual. Okay, so in that window, or the study window that we have taken, study period, some of the individuals do not have the event yet. They have the event, or they whatever be the event, whether it's death, whether it's getting a job, or defaulting on an account, hasn't really happened by the end of the study. Okay, it has happened after that, and we don't know when it is happening, but still we can include this observation in the data set. Some individuals, they drop out of the study in the middle of the study. Okay, we do not know what is happening with these individuals when they drop off from the study in the middle of the study, and we have no clue what exactly is happening to these individuals. You can see on the screen, I have a small picture. um, I'm very bad at drawing pictures, so excuse me for that. You have a starting point here, so that is the starting of the study, and then you have an end period of the study. So I'm observing uh, the event from the start to the end. That is my study window. There are four people in my population. Of course, there will be so many of them, but for example sake, let's say there are four people, four individuals I am studying. The first individual starts from the very beginning, and then uh, it reaches up to the end, and this event hasn't happened yet. Okay, let's assume that the event is death. That means the individual is still alive. We don't know when he's going to be dying. So we do not have information on the event for that individual, for individual 1. For individual 2, it starts at the beginning and its drop off in the middle of the study. It doesn't continue. We don't know what is happening with this individual. So first individual, second individual, both are censored events. The third individual here is the one which is a staggered entry, or it entered the study not at the beginning. It enters the study in the middle of the study, or is somewhere in the middle. Okay, and then the event happened before the end. Okay, so that's not a censored event. And then the fourth individual, again a staggered entry, doesn't start or doesn't enter the study from the very beginning, but by the time it is ending, or the study period is ending, we have had the event happening for that individual. Okay, so why it is happening and why it's not happening, well, that is not something important for us. The only thing that is important for us is that when exactly is the event happening. Okay, what is the time, exact time? That is the most important thing in the survival model. Some definitions, some mathematical definitions. Density function. First thing, I'll define what is a density function. you must be knowing what is a density function in a probability density probability distribution. It's exactly the same. To define it, it's the probability of happening an event at time t. At time t, what is the probability that an event is going to happen? It's an unconditional probability, or without any condition. What is the probability that an event is going to happen at time t? The next function that I'm going to define is survival function, denoted as s of t. So which is probability that an event happens, or the event happens after time t. Okay, capital T is when the event happens. Okay, so in a layman language we can say that what is the probability that I'm going to survive beyond first year, beyond second year, beyond third year, and so on. Okay, so that's the survival function. It gives the probability of surviving beyond a point. The third thing is this hazard function. It's the instantaneous event rate, otherwise known as the force of mortality. We define it as given that a patient has survived till time t, what is the probability that it's going to die at time t? Or it's the conditional probability. Okay. Using the same example, we can define hazard function. A particular patient has survived till or up to the second year. What is the probability that it's going to die on the very second year itself? Okay, so we have the information till the second year, and we want to know what's the probability it's going to die on the same time, or the instantaneous time. That is something about the hazard function. We estimate these functions. Actually, we estimate only the survival function. We can get the probability density function and the hazard function directly from the survival function. So we only care about the survival function. We estimate the survival function in survival analysis using a particular type of estimation known as Kaplan Mayer estimation of survival function. Very simple one. Kaplan Mayer survival function estimates probability of survival up to each time in data from the beginning to the follow-up time in such a way that finally we just get to know that what is the unconditional survival probability at each point in time. Okay, so what is the unconditional survival probability at time 1, time 2, time 3 up to time n? Okay, if there are n periods in the study window. To understand it better, let me give you an example. There are 50 patients. In the time 1 person died. So what's the probability that somebody is going to survive beyond time 1? It is 49 by 50. If you know the basic rules of probability, it's the number of surviving by total number of population. Okay, so 49 by 50 is the probability that you are going to survive beyond time 1. Hence, the conditional probability that you are going to survive beyond time 1 is 49 by 50. I'll denote it as P of 1. Similarly, 49 people enters the population or enters the study at time 2. Out of 49, 2 people die in time 2. So what's the probability, conditional probability, that you are going to survive beyond time 2? 47 by 49. So P of 2 is 47 by 49. But survival function or survival probability is actually the unconditional probability, not the conditional probability. How do we get unconditional probability of surviving beyond time t? First of all, we denote it as S of 2. Okay, so S of 2 is nothing but product of conditional probability of survival at time 1 multiplied by the conditional probability of surviving beyond time 2. Okay, it's the basic probability rule. One event happening at point time one, second event happening at time two. What's the probability that jointly both are happening? So it's the multiplication given that they are independent to each other. So A sub 2 is the unconditional survival probability, and that is very important for us. And we are going to estimate the S function or the survival function using the Kaplan Mayer estimation. Well, mathematically, as I said, it's the product of the conditional probability of survival beyond time t, and then you can just continue, and you can just go on doing that, go on increasing the t value. In the last example, we just saw only up to time two. We can you know use the same formula for time 3, time 4, time 5, anything up to time n. Okay, just to generalize it, your survival estimate is nothing but is the product of your ni, total number of population entering at time t, minus number of people dying or number of events happening, which is denoted as di, by total number of population at time t. Okay. We estimate survival function in SAS. Of course, we can use any software. In SAS, you get a product limit survival estimates, otherwise known as the life table. Life table is something that I showed you some time back. It gives you how the survival probability is computed. You can see 500 people enter the population, then no event happens. Survival probability is 1. Okay, because 500 by 500 is equal to 1. Okay, and then 8 people dies in the time 2. Okay, survival probability gets decreased to 0.98. I can see on the screen, and then it keeps on going down. Ideally, if you continue doing that for infinite period of time, it should go down to 0. But then we have a limitation, we have a limited study period, and we'll see how the survival curve look like. Well, survival curve is nothing but a plot of survival values. Okay, it starts with 1 and then it slowly decreases. Let us see how it looks. Survival curve looks like this. As I said, it starts with 1 because at time 0 nobody will die, right? Because it's just the starting of the study period. So all the people in the population are now surviving. So the probability that you are going to survive beyond this time 0 is 100%. Okay, so that's probability of 1, and then slowly as people die with time, the survival probability decreases with time. Uh, as I said, the survival probability decreases with time. uh, if you continue doing that for infinite period of time, the survival function will go down to 0. It will touch the x-axis. There are several applications of survival analysis. It's very much used in the healthcare industry. Um, the event of interest in healthcare industry is the whether a patient is dying or is surviving. It's very important to know that how many patients are going to survive beyond the first year, beyond the second year, third year of the operation or the treatment that has been given to the patient. It's very well known in insurance industry as well, because for pricing purposes, the insurance provider need to know that how many people are going to die. uh, what's the probability that n number of or x number of people are going to die in the first year, in the second year, and so on. And based on that, it charges or it it sets the price of different insurance product. So that's about survival analysis theory. In the next video, I'll show you how to perform survival analysis, or how to build a survival model using SAS. I'll take an example and do it for you using SAS. Thank you.